In the previous two videos, we placed 4 guide tube bundles into this targeting cone. In the first video, we placed 2 9x probe bundles into the hippocampus bilaterally here and here at slightly different anterior-posterior coordinates. And in the second video, we placed 2 7x probe bundles into the nucleus accumbens here and here at the same anterior coordinate. In this video, we're going to place 4x bundles into the ventral tegmental area. And since we're going to be using 4x bundles instead of 7x or 9x bundles, I'm going to collapse this 7x, 9x folder, and then I'm going to expand this 4x bundle folder. Now I have 12 4x bundles available to me. They're all hidden right now, but I'm going to unhide the first one. And you see that it appears right at bregma. And in this case, the 4x bundle is largely occluded by the bregma hole because the diameter of the bundle is not much bigger than the diameter of the bregma hole. So this is slightly annoying, but when we move the probe bundle off of bregma, we'll be able to visualize the whole thing. So the first thing I'm going to do here is rotate this bundle around the y-axis. We've already seen how to do this in previous videos. I'll go to Move Component, Rotate Component, by delta XYZ. In this case, I'm going to rotate by 45 degrees around the y-axis, apply, and this is the orientation that I prefer for this particular implant. Hit the check mark, and now that's done. Next, I'm going to move the probe bundle, so I need to click on it again, and this occlusion makes that a little bit tricky, so I'm going to zoom in real close so I can click on it. Now I've selected a piece of the probe so I can move it. I'll go up to Move Component, by delta XYZ, and in this case I'm going to move posterior to bregma. Now my target coordinate for this probe is 5.3 millimeters posterior to bregma. That's where the part of the ventral tegmental area that I want to hit is located. But I'm going to play a little trick here. Rather than moving this probe to exactly the target coordinate of 5.3 millimeters posterior to bregma, I'm going to move it to only 5.0 millimeters posterior, and then I'm going to put this probe on one side of the brain, and then the probe that I put on the other side I'll move 5.6 millimeters posterior to bregma, so that I'll have 2 probes on each side of the brain that straddle the target coordinate by about 0.3 millimeters on either side. That is, this probe will be 0.3 millimeters anterior to my target, and the one on the other side will be 0.3 millimeters posterior to my target. And the reason I'm doing this is because it will buy me a little bit more margin of error if I'm off in my placements when I do my surgery, and we'll see more about why that's the case later on. So I'm going to go to my Z coordinate here and position this probe at minus 5 millimeters posterior to bregma. Click Apply, and my probe has now moved out to 5 millimeters posterior to bregma. I'll click the green check mark to accept that move. And now you can see that rather annoyingly the bregma hole is still occluding this. This is a rendering problem with SolidWorks, and I'll show you how to fix that right now. The simplest way to deal with this is to just do a quick rebuild by clicking on this icon up here, Rebuild. It'll take a bit of time. You can hit Close, and now we can see the entire part. Now let me go to my standard view, click on the frontal view, and zoom in. It's time now for me to insert a figure so I can visualize where these probes are going to go. So I'm going to briefly expand my figures folder here. My target coordinate in this case is actually 5.3 millimeters posterior to bregma. And figure 41, if I show that, is actually located right at 5.3 millimeters posterior to bregma. Now, as I said before, I deliberately placed this a little bit anterior to that target at 5.0 millimeters. And in this side view, you can see that we are indeed sitting a little bit anterior to that target plane. Let me go back to my frontal view here. And my target in this case is the ventral tegmental area is very close to the midline, like right here. So as we did in the second video, implanting the 7x bundle into the nucleus accumbens, we're going to need a little bit of an angle here so that we don't have to drill holes right on the midline and risk rupturing that midline sinus. So what I'm going to do is, before I move this probe bundle laterally, I'm first going to select it and rotate it by delta XYZ In this case, I'm going to be rotating around the z-axis, and I'm going to choose a 12-degree angle in this case. And now I've got a pretty steep 12-degree angle there, and I'm happy with that, so I'll click check. And now I'm ready to move my probe bundle laterally to a coordinate that will pass these probes through the VTA. Now, as in the prior video where we were targeting the nucleus accumbens, this angle is going to alter our lateral coordinate in some way that we don't quite know what it is yet. And we could figure that out with trigonometry, or we could just do it the simple way visually using SolidWorks. And that's what we're going to do. So I'm going to click here on one of these probe bundles so that I can now move it. I'm going to move it laterally by delta XYZ. In this case, I'm going to put this probe into the right side of the brain, which means I have to move it leftward on the screen because we're viewing from the front. And as we did before in the prior video, I'm going to say minus 0.2 so that I can move in increments of 0.2 millimeters. And I'm going to count off as I click apply so I keep track of how far I've moved. So one apply is 0.2 millimeters, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 2.2. Now I'm getting pretty close here, and I'm going to do one more increment. I think this time I'm going to reduce the size of the increment to 0.1, so if I hit apply now, I'll get to 2.3 millimeters. And I'm going to stop there, and I'll explain what I'm trying to do. So let me hit check and accept that. What I'm planning to do here is the following. I'm going to use these two probe tracks here to inject a fluid cannula so that I can inject a viral vector into the VTA. And then I'm going to remove the fluid cannula and put a laser fiber down through those exact same probe tracks so that I can know that I'm stimulating the exact same site where I injected my virus. The virus is going to carry channel rhodopsin, so I want my light stimulus to illuminate the exact same part of the brain where I've injected my virus. And the reason why I've chosen to position my probes a little bit anterior to my target coordinate is to buy myself some margin of error when I do my surgery and where I do those virus injections. So as you can see, the two probes that I'm going to use to inject my virus, the probe tracks where the virus is going to go, one of them is right in the plane that I'm targeting, the other is a bit ahead of it, and then when I position a probe on the other side of the brain, I'm going to put that other probe a little bit behind it, so that even if my surgery is a little bit off, at least one of these fluid injector cannula probes is likely to hit exactly the part of the VTA that I'm targeting, so I'll be able to stimulate the neurons that I ultimately want to stimulate. So now that that game plan is clear, let's go ahead and position the other VTA probe target bundle. What I'm going to do is take a bottom view and go back to my 4X bundles folder and make another 4X bundle visible. Again, it appears here on top of the bregma hole and is partially occluded by it. The first thing I'm going to do is rotate it by delta XYZ around the y-axis at 45 degrees. Get the orientation that I wish. Hit check. Now I need to zoom in and click on a part of the component, move it by delta XYZ, and this time I'm going to go, as I said, 5.6 millimeters posterior to bregma. So that's going to be minus 5.6 along the z-axis. Apply. It moves back. I'll hit check to approve that. Again, to solve this annoying rendering error in SolidWorks, I'll use this rebuild icon. I'll wait a moment for that to work, get rid of my error. There is my probe. Now I'll zoom in again, click on a part of the component so I can do a rotation by XYZ. This time it's going to be around the z-axis. I've got to do that 12-degree rotation that I used for the other probe, and I'm going to make it a minus 12 degree this time because we're going on to the opposite side of the brain. There we have it. Accept that. Now I'll click on it again, move component. we've already figured out what our lateral coordinate is, so by delta xyz I'm going to be going 2.3 millimeters this time in the positive x direction to put this into the left side of the brain. And there we go. You can see that these are now exactly the same distance from the midline on opposite sides, but they are at slightly different anterior-posterior coordinates. Now what I've got planned is to inject virus into this probe and this probe, and if all goes well, if the surgery is perfect, that will put my virus right into the VTA in the target plane. But I'm also going to inject virus into this probe, and so that if I'm a little bit off in my surgery, I should still get at least some of the virus into the targeted area of the VTA, even if I'm off in the anterior-posterior direction. And then these other probes that aren't going to be used for virus, I'm going to put electrodes into there so that I can record neurons and examine their responses to the optogenetic stimulation. So I need to click the green check mark to accept that movement. And now all that remains for me to do is to flip this over and look in from the top and drill my holes, and then I'll be ready to move on to the next step. So as we've done before, to drill the holes we need to go to Assembly Features and click Extruded Cut. I'm going to be prompted to select the plane to draw my cut circle, and I'm going to do that by clicking on top of one of the probes. I'm going to zoom in, and I'll click the circle tool, hold down the left mouse button while clicking the center of my probe, zoom out till the circle turns orange, let go, hit check. Uncheck Exit Sketch, get rid of my error, click Through All Both, hit the green check mark. There's my hole. Now I need to do the same on the other side. So Assembly Features, Extruded Cut, choose the plane, zoom on in, circle tool, by now this should all be very familiar, zoom out, check mark, unclick Exit Sketch, close. Don't forget to go to the Through All Both selection, click the check mark, and there we are. We have all 6 of our holes drilled now. 2 for the nucleus accumbens, 2 for the hippocampus, and 2 for the ventral tegmental area. And in the next video, I'm going to show you how to trim the bottom of the drive so that we make space for all the securing screws and for the acrylic to form a tight grip with the skull.